All right, last step, our last concept here is solving equations that have fractions in them. We have y plus 3/4 equals negative 2/3, and oops, that's not looking too good there. And then we have negative 8/9 times x plus 5/6. Okay. Um, this This problem here, well, actually both of them, you might remember that we had problems like this before where we'd have like y plus 3 equals 10. And you had problems like this, 3x equals 30. And they were one-step equations that you did the opposite for. Y plus 3 equals 10. Well, we learned that you would add negative 3 on this side and also this side. So you get the positive and negative 3's went away. You get y equals 7. So we did that. Over here, it was the opposite operation. For adding 3, we added negative 3. Some people choose to subtract. Over here, they're multiplying, so we divide. So you take that 3x, which is 3 times x, you divide by 3, x equals 10. This is really the same thing up here. See, they're just simply adding fractions instead of whole numbers. We're going to have to add a negative 3/4 to both sides to get y by itself. Over here, they're multiplying by negative 8/9. We can divide by 8/9, but it's going to get a little bit messy if we do that. Let me see if I can split this page and maybe hide this here for some extra room. Oops, nope, it's over here now. Oh, it's playing games. Okay. All right, add page. So we have this over here, and again, this stuff hopefully looks somewhat familiar. On this side, let's deal with the fractions. So we got y plus 3/4 equals negative 2/3, just like that. We'll do y plus 3/4. I'm going to add negative 3/4 to this side to get rid of the positive that was being added. And then equals negative 2/3. And I'll have to, whatever I do to one side, we have to do to the other. That's the addition property of equality in math. So over here, those zero out, the property of opposites. We're left with y equals. Over here, we have negative 2/3 plus negative 3/4. A negative add a negative. Negative plus negative is just a great big negative number. So I know it's going to be negative. I cannot add these together until they have common denominators. I have a 3 and a 4. Their lowest common multiple of 3 and 4 is 12. So I'm going to change them. Let me see here. Where's my pen colors? Let's convert 2/3. We'll multiply both here by 4. And we'll multiply over here both these by 3. So 2 times 4 is 8. 3 times 4 is 12. That was negative. Adding a negative 3 times 3 is 9. 4 times 3 is 12. Again, negative plus negative. I know ultimately this is going to be a negative answer. 8 and 9. Well, now that we have common denominators, all we have to do is add the numerators together. So we got this negative 8 plus negative 9. That's a total of negative 17. Negative 17. Keep my denominator 12s. We can simplify that to a mixed number. 12 goes into 17 once with 5 left over. And it was a negative. And we're done. So you can see there how it's very similar to this. It's just you're dealing with a fraction instead of a whole number. Now, over here, this is the one that might look a little less familiar because there's another way you can do it. Let's see if this will work. There we go. Negative 8/9 x equals 5/6. 5/6. It's a tricky one to say. We learned before we had 3 multiplied by a variable equals 30. We had to divide both sides by 3 to kind of undo the multiplication. You can do that over here. They're multiplying by -8/9. You could say, well, I'm going to divide by -8/9 on both sides. This just looks scary to a lot of people. It's called a complex fraction. Fractions over fractions. It does, I mean, divide out. This would go away. You'd be left with x. And then on the other side, we have 5/6. I'm going to write this 5/6 divided by -8/9. And we'll follow the rules for dividing. 5/6. Division becomes multiplying by the reciprocal. It still stays negative. It's going to become 9/8 though, like this. We can do a little reducing ahead of time if we want to, just to save us having to simplify later on. The 6 and the 9, greatest common factor is 3. Divide them both by 3 and you get 2 and 3. Nothing we can do with the 5 and the 8. 5 and 2, 3 and 8. 5 times 3 is 15. 2 times 8 is 16. And we know we've got a positive times a negative. That equals a negative. So our answer is -15/16. You can see here, dividing by this fraction on this side, dividing by this fraction ultimately means that we have to multiply by its reciprocal. So we can save ourselves a little bit of time and effort if we actually add a page in here. So we can keep that there for a second. But this is how you might consider doing it. You got -8/9 times x. And if this way over here makes more sense to you, by all means, keep doing it. But what I had taught earlier was that you can clear away any fraction, make it become 1 by multiplying that fraction by its reciprocal. So in this case, -9/8. If I multiply by -9/8 onto the left side, I have to multiply on the right side by 9/8. A fraction times its reciprocal is always 1. So those will be gone because 1 times x is x. On this side, you can see that we're down to multiplying this fraction times this fraction, which is what we have going on over here, right? 5/6 times -9/8. Here it is. This just saves us a little bit of work and setup that we otherwise have to do. So if you can't remember what to do with this, go ahead and think it through just like we did before, where they're multiplying, I need to divide. You divide both sides, work it through like that. If you can remember that you can get rid of a fraction that's sitting there being with this multiplication by just multiplying by its reciprocal, well, you can do that. Same thing here. It's going to reduce to 2 and 3, and I end up with 15/16 pretty easily, pretty quick. I think this is a nice way, keeping in mind that reciprocal, nice way to get those fractions and those equations with fractions solved.